Hello, welcome back. In this video, we'll discuss the ball milling method. A ball mill is a device used to blend materials in the material science and engineering. A ball mill consists of a hollow cylindrical shell which rotates about an axis. The axis of the shell may be either horizontal or inclined at a small angle to the horizontal. The ball milling synthesis is a part of top-down methods of synthesizing nanomaterials. A ball mill consists of a hollow cylindrical shell. The ball mill rotates about a horizontal axis. The axis of the shell may be horizontal or inclined at a small angle to the horizontal. The ball mill is partially filled with balls which may be made of chrome steel, stainless steel, ceramic or rubber. The ball mill is partially filled with balls that are made with chrome steel, stainless steel, ceramic or rubber. And these balls, they form the grinding media. The grinding media is the balls in the ball mill method. The inner surface of the shell is generally coated with certain material that can resist the damage due to the movement of the balls. Generally, the lining material is rubber or manganese steel sheet. Now we shall see the working principle. The ball mill works on two principles. The first one is impact and second one is attrition or friction. The cross section of the ball mill looks like this. We have the cylindrical shell. Since we are looking at the vertical cross section of the ball mill, it looks like a circle. And we have the small circles within that. They are the balls, and the small black dots, it is the precursor material. When the shell rotates in the counterclockwise direction, we see that the balls also would move in the same direction and they reach almost close to the top of the shell. From there, the balls, they fall on the precursor medium. While doing so, they break the precursor medium into small pieces. So the size reduction takes place by the impact. Impact leads to size reduction. Since this is a top-down approach, the material is taken in bulk form. As and when the ball falls on the pieces of the precursor medium, the pieces are broken into further small pieces. As a result, size reduction takes place. So due to the friction between the balls and the feed and due to the rotation of the balls, attrition takes place. So this causes production of fine powder. Now we shall discuss about the grinding media. What is the grinding media here? The grinding media is the balls. Many types of grinding media are suitable for use in the ball mill, each material having its own specific properties and advantages. The key properties of grinding media should be taken into consideration at the time of their selection are its size of the grinding media, density, hardness, and composition. We shall look at these things in detail. Let us see how the size of grinding media is going to affect. Smaller the media particles, the smaller the size of the particles of final product. However, grinding media particles should be substantially larger than the largest pieces of the material which is to be ground by the mill. The grinding media particles should be substantially larger than the largest pieces of the material which is to be ground by the mill. Here the point is, the grinding media means the balls, they should be substantially larger than the largest pieces of the material that is to be ground by the mill. So if you have, say, 1 millimeter is the dimension of the largest piece of the material to be ground, then we should have at least 10 millimeters or even higher dimensions for the grinding media, that is the balls. The second aspect is density. The density of the grinding media should be more than the density of the material being ground. The density of the grinding media should be more than the density of the material being ground. If the density of the grinding medium is not more than the density of the material being ground, then the grinding media or the balls, they start floating. That is an undesired quality. So the density of the grinding media should be more than the density of the material being ground. Next we shall see the hardness. The grinding media should be hard enough to grind the material, but its hardness should not damage the inner lining of the shell. The fourth one is composition. The composition of the grinding media should not impact the material that is being ground. Now we shall see the types of ball mills. Here we shall discuss generally the types of ball mills that are largely used in nanotechnology or in synthesizing the nanoparticles or nanomaterials. Vibrating ball mill, low energy tumbling ball mill, thirdly high energy ball mill. Now we shall see the advantages of ball mill. The first advantage is cost of installation and grinding medium is low, hence inexpensive process. Ball milling is suitable for both batch and continuous operation. Thirdly, ball milling is suitable for both open and closed circuit grinding. Materials of any hardness can be grounded. Small particles with a narrow size distribution can be produced. Size distribution means we are referring to the statistical distribution. The size distribution ranges from 2 to 20 nanometers. So these are some of the advantages of the ball milling. In this video, we have started our discussion by stating that ball milling is a top-down synthesis method of nanoparticles or nanomaterials. Ball mill consists of a hollow cylindrical shell. Ball mill rotates about its axis. Axis may be horizontal or inclined at a small angle with the horizontal. It is partially filled with balls that are made with chrome steel, stainless steel, ceramic or rubber. Grinding media is the balls in the ball mill method. We have seen the structure of a ball mill. We have seen the cross section of a typical ball mill. The principle involves two different methods. One is impact. The other one is attrition. Impact mechanism causes the size reduction. Friction results in the production of powder. We have seen the desired qualities of the grinding media, that is the balls in the ball milling. They are size, density, hardness and composition. We have seen the types of ball mills: vibrating ball mill, low energy tumbling ball mill, high energy ball mill. We have seen the advantages of the ball mills. The cost of grinding media and the installation is low. Ball milling is suitable for both batch and continuous operation. Suitable for both open and closed circuit grinding. Materials of any hardness can be grounded. Small particles with a narrow size distribution can be produced. Thank you.